All right. Math 1314. Day 13. Chapter 6. Systems of equations. When we say system, what we're talking about there is one or more equations with one or more variables. So one or more equations with one or more variables. Basically, it says the number of variables indicate the number of equations needed. So if you have, example, if you have two variables, X and Y, we will have two equations. X plus Y equals 5, and then 2X plus 3Y equals 6. If you have three variables, then you have three equations. If you have three variables, X, Y, and Z, then you will have three equations. Equation 1, X plus Y plus Z equals 2. 2X minus 3Y minus Z equals 5. Negative 5X plus Y negative 3Z equals negative 2. So basically, that's what it says. If you have three variables, you have three equations. It makes it much easier to solve that way. All right, so that's what we call a system. It has two or more equations. Let's say it should be two or more, not one or more. Because if you have one, that's not a system. That's simply an equation. So we put two or more. Two or more equations, two more variables. We've looked at this kind of earlier in the semester. If you have two lines, then only four possibilities can occur. The parallel lines, and they have no solutions. You have the perpendicular. You only have one solution. Right there. You have the same line, which means you have infinite number of solutions. Each point of that graph is a solution. Then you have other, which only has one solution also. Right, so we talked about this earlier. You see that there's only one of them that has no solutions. That's how we differentiate whether if it has a solution or not. If we say it's consistent. Consistent. If it has one or more solutions. Two lines are consistent if they have one or more solutions. They're inconsistent if they have no solution. So parallel lines are inconsistent. Everything else is consistent. Now, we have two other types of designations. We say two lines are dependent. Dependent. Two lines are dependent. If you can make one equation into the other, by simply multiplying a number. To it. Then it's dependent. Case in point. Here we have two equations. This equation is dependent because if I multiply by 4, then it'll equal the second. This is equation 1, equation 2. That's what we call dependent. If that can't happen, then we say it's independent. If they have no multiples in common. Basically, you say it's not dependent. Right. We're going to look at 4 ways of solving systems of equations, which we did one earlier in the semester by we're going to talk about 4 methods of solving systems of equations. The first is pi graphing. The second is a method called substitution. Third is the elimination. And the fourth is Cramer's rule. Each one has their pluses and minuses, but personally, I prefer Cramer's rule. And we'll see why in a minute. All right. By graphing. Here are the steps. Set both equations to y equals mx plus b. That's the slope-intercept form. Plot value on the y-axis. Remember, the b value is the y-intercept, so plot the y-intercept. From B, follow the slope M to the next point. And connect the dots. Do that to both equations, and the solution is where they intersect, if any. Do that to both equations, or set both equations, y equals mx plus b, plot the b, follow the slope, connect the dots, and then draw both lines to see if they cross. All right, so here we go. Let's look at this. X minus y equals 5. 2x plus y equals 1. So the first thing we have to do is make these into y equals mx plus b. So this one, we have to subtract x from both sides. So we got negative y equals negative x plus 5. Change the signs. Y equals positive x minus 5. And the second one, just move the 2x over. And there you have it. From earlier in the book, we're in a chapter, we know that since the slopes are different, we're going to have one solution. Then let's go ahead and graph them. So the first one, at negative 5, 1, 2, 3, 4, 5. So at negative 5, we put our first dot. The slope is 1 over 1, so up 1 over 1. All right, so from there, connect the dots. That's line 1. Now the second one. Positive 1, down 2 over 1. This is that slope. So we roughly see the intercept is at 2, -3. And that's our solution, if it's accurate. All right, so that's graphing. Set them both equals to stuff we've been doing. Now substitution, we use same equation to see what we get. So we have x minus y equals 5. 2x plus y equals 1. This is line 1. This is line 2. In substitution, choose either equation and solve for either variable. It doesn't matter. So for simplicity purposes, since this is a positive y, let's solve for y. So I'm taking line 2. I'm solving for y. So I subtract 2x from both sides. What you just found there, that is the formula for the y value of the answer. So what you just found after the first step, that's the formula for the y value of the answer. Second step. Take the other equation, the one you didn't use. So in this case, it's line 1. And substitute the equation from step 1 into the variable. So here's the equation from step 1. I know that anywhere I see a y, it equals that. So since it's after a minus sign, I put in parentheses. So it's minus 2x plus 1 equals 5. Since I used line 2 in the first step, solve for y, I take the other equation. Anywhere I see a y, I put negative 2x plus 1. And solve for the remaining variable. So negative times negative is a positive, 2x. Negative times positive is a negative 1. 2x plus x is 3x. add 1 to both sides. 3x equals 6. Divide by 3, x equals 2. That will give you the x value of the answer of the solution. So plug that value into the equation from step 1 to find the other solution value. So we know that from the first step, we had y equals negative 2x plus 1. So anywhere I see an x, I put a 2. Negative 4 plus 1. That is your solution. So our solution is at 2, negative 3. All right, let's look at the elimination method. We use the same equation. X minus y equals 5. 2x plus y equals 1. In this method, place both equations into standard form. Remember, standard form is ax plus by equals c. So all the variables to one side, number the other. Check, it's there. Decide on which variable you want to eliminate. Okay, this is the limit. In order to eliminate, the coefficients must be opposites. What does that mean? Same number, different sign. So we have here, we have x minus y equals 5, 2x plus y equals 1. I want to get rid of the y value because the coefficients are opposite signs, but same number. you may need, at this point, you may need to multiply one or both equations to make them so. In other words, if it wasn't opposite signs and same numbers, we'd have to multiply one or both to make it so. That's the next, I'll show you the next example. Add the two equations. Here, one of the variables should eliminate. So add these two together. 1 plus 2 is 3. Negative 1y, the y's cancel. 5 plus 1 is 6. Solve for the only variable. So we add them. Only thing we have left is 3 or x. So we divide by 3 both sides. X equals 2. That is one of your solution values. Now plug that value into either of the original equations and solve for the remaining variable. So here, plug that value just found into the any one of the original equations, and that's your remaining variable. So we know that x equals 2. I look back in the original equations. I'll use the first one. Anywhere I see an x, I put a 2. Solve for y. Change the signs. So my solution is at x equals 2 and y equals -3. That's the elimination method. All right, let's do another example. The same 3 methods. Now I'm not going to do the graphing method because in this next example, you'll see that graphing wouldn't be the best idea in the world. Okay. 4x plus 3y equals 4. Negative 5x plus 2y equals 15. This is line 1. That's equation 1. And this is equation 2. Let's do substitution first. So remember, we have to first choose a variable, an equation first, and then a variable to solve for. Doesn't matter which one you pick. So let's choose the first equation. And we want for x, solve for x. So subtract the 3y, so we have 4x equals negative 3y plus 4. Divide both sides by 4. Remember, this is going to be our formula for our x value. So since I used line 1 and solve for x, I now got to take line 2 and solve for y. So anywhere I see an x, I put that huge equation in there. I substitute it in there. Okay, it looks ugly, yes. All I do is I take my x value, plug it inside there, put in parentheses. I have an equal sign in fractions, so I have to multiply each term by the LCD. Here's the first term. There's a second term. There's the third term. The LCD is 4. Reduce. So I have negative 5, negative 3y plus 4. 4 times 2y, 4 times 15. So I get rid of the fractions. Now get rid of the parentheses. Negative, negative is a positive. 5 times 3 is 15. Negative, positive is a negative. 5 times 4 is 20. Positive, positive. 4 times 2 is 8. 4 times 15 is 16. Combine like terms. Whenever you get rid of parentheses, always combine like terms. 15 plus 8 is 23. Minus 20 equals 60. Add 20. 23y equals 80. And divide by 23. So I know that my y is 80 over 23. Now, since this is my y value, I got to go back to the x value, plug it in there, solve for my x. You know that y equals 80 over 23. And the formula for x is negative 3y plus 4. Anywhere I see a y, I put that in there. So x is equal to -3 times 80 over 23 plus 4 over 4. Nothing cancels. So we have positive negatives, negative 240 over 23 plus 4 over 1 over 4. We have to combine these two first. Since we have different denominators, this one has 23, this one has 1, so 23 over 23. Negative 240, 23 times 4. 1292 over 23. $240 is bigger, so the answer is negative. 240 minus 92. So it's negative 148. Now we have a fraction over a fraction. Take the top one, leave it alone. Multiply by the flip of the bottom. Can anything cancel? 4. Well, 2 goes in both of those. So 2 goes in that twice. 2 goes in there 74 times. 2 goes into 73. So the answer is x equals negative 37 over 23. There's my XY solution. That's where they intersect. All right, let's see what happens now using the elimination method. So we have 4x plus 3y equals 4. Negative 5x plus 2y equals 15. For the elimination method, remember we have to choose a variable. This is line 1. This is line 2. But to choose a variable so that when we add the two equations, they cancel out. So I choose, remember, it has to have same numbers, different signs. These are same. It'd be easier if I choose X. Choose X. Now, they have different signs, they have to have the same number. So if I multiply the first equation by 5 and the second equation by 4, five times 4 is 20. 5 times 3 is 15. 5 times 4 is 20. Positive, negatives, and negative. 4 times 5 is 20. 4 times 2 is 8. 4 times 15 is 60. So I chose X to eliminate. They have the same sign, different signs. So when I add these two equations, those cancel. Get 23y over 80. So y equals 80 over 23. All right, and since we have y, we could take this and plug it into either one of the original equations, or we can repeat the process we just did here. Since we got rid of the x in the first one, let's get rid of the y's here. They're both positive. So one of them, I have to multiply by one of them has to be negative. So this one, 3 and 2, the easiest number is a 6. So if I multiply by -2 in that one, and a +3 here, -2 times 4 is -8x. Positive is negative, 2 times 3 is 6. Negative positive is negative, 2 times 4 is 8. -15. Positive is a positive, 6y equals 45. Yeah, so now I have the same numbers, different signs. So when I add them, the y's are gone. 15 plus 8 is -23. 45 minus 8 is 37. X. Change of signs. So we have 23x equals -37. X equals -37 over 23. That's my point of intersection. All right, those are the three primary methods: graphing, substitution, elimination. I want to show you now a method I like because it doesn't require all this really moving around. All it really requires is multiplication and addition, and subtraction. Let me get some more paper. Okay, so we use the same equations. This one's called Cramer's rule. Uses matrices. What is a matrix? A matrix is a graphic replication of a system of equations. The columns represent the variables. The rows represent the line number or the equation. The values inside are the coefficients. So inside the matrices, those box, all you'll have are numbers. There's no letters. So example, what if we had this? Here's an example. What we would do so the first row, first column is a 2, because this is the line number. This represents the coefficients of x and y. So the coefficient of x is 2, coefficient of y is 5, and the solution is 3. Negative 7x, negative 1y, and 0 for the coefficient. That's all there is to it. That's the first part. That's just setting it up. Now the calculations we determine or find we have to find the discriminants. The discriminant of a matrix. It's A1, A2, A3, A4. So we have a matrix. Multiply these two together first. So it's A1 times A4 minus that discriminant, A2 times A3. And that's all there is to it. So from this example up here, two, 5, negative 7, negative 1. So this main diagonal, so I have 2 times negative 1 minus negative 7 times 5. Positive negative is a negative. 1 times 2 is 2. Positive times negative is negative, times negative is a positive. 7 times 5 is 35. 35 minus 2 is 33. And there's the value. That's just the determinant or discriminant. All right, let's see. Now that's just my. We have to also examine some other parts because this is just the main part. We haven't incorporated the answers yet and everything. Let's figure out how to find X and Y. So A1, A2, I'll call this one B1, B2. And since those are the answers, that's solution 1, solution 2, or answer 1, answer 2. The first thing you do is find the main discriminant or determinant. So A1 times B2 minus A2 times B1. That gives you the D. Now, what about the X component? To find dx, we take the solutions, put them in the first column. Solution 1, solution 2, leave the second column alone. So I just took these, cut and paste, put in there, leave the second one alone. So it's S1 times B2 minus A2 times S2. That finds you dx. dy. Here's, remember, this is the X column, this is the Y column. So take the answer, put them in place of the Y column for the dy. Leave the first one alone. So leave the first column alone and put the solutions in the Y column. There's the Y's are here, and here's the X's. A1 times S2 minus S1 times B1. Again, all it is multiplication and addition or subtraction. So to find our X value, we take dx over d. To find a Y value, we take dy over d, and there you have it. Our answers, wherever those are. All right, let's look at what happens here. Our first example. We're going to use what we did our first time. So the first thing we have to do is convert it to matrix notification. Or notation, notification. Remember, the first column is our X's, the second is our Y's, row 1, row 2. So the coefficients, 1, -1, and 5. 2, +1, and 1. Now, this is all we use here on out. So the D, 1, -1, 2, 1. 1 times 1 minus -1 times 2. 1 times 1 is 1. -1 times 2 is -2. Negative and negative becomes a positive. So my D value is 3. For dx, since I'm looking for the X values, I take the answers and put them in the X column. So it's 5, 1 in the first column. Leave the Y's alone. And do it. 5 times 1 minus -1 times 1. 5 times 1 is 5. -1 times 1 is -1. That becomes a plus. So dx is 5 plus 1 is 6. To find dy, go back to the original equation, leave the x alone, that's 1 and 2. Now I put the answer in the y column. So it's y1. One times 1 minus 2 times 5. 1 times 1 is 1, 2 times 5 is 10. So dy is negative 9. Find x. We put dx over d. Dx is 6. D was 3. 6 divided by 3 is 2. To find y, dy over d, negative 9 over 3 is negative 3. So 2, negative 3 is my solution. All right, let's look at the second example we did. The one that had uglier numbers. 4x plus 3y negative 5x plus 2y equals 15. So these are the coefficients of the x and the y. So it's 4, 3, 4, negative 5, 2, 15. So the original equation is your d. 4 times 2 minus negative 5 times 3. 4 times 2 is 8. Negative 5 times 3 is negative 15. That becomes a plus. 8 plus 15 is 23. Dx, I take the answer and put it in place of x. So my first column is going to be 4 and 15. Leave the y's alone. 3, 2. Four times 2 minus 15 times 3. 8 minus 45. So dx is negative 37. Then dy. Again, dy, I leave the x values alone, so it's 4, negative 5. And I put the answers in the y column. So it's 4, 15. Four times 15 minus negative 5 times 4. 4 times 15 is 60. Minus -5 times 4 is -20. That changes to a plus. So dy is 60 plus 20 is 80. So the x value is dx over d. dx is -37. D is 23. The y value is dy over d. 80 over 23. Much easier.
Oh, Professor,
Yes,
this is amazing, first of all. Second, I have a question.
yes, please.
Would there be a time where we can't use this Kramer's rule and have to use the other three that you just showed us?
No, that's just it. That's the beautiful thing about it is no matter what happens here, let's say your d becomes 0. Then you know there's no solution because all of them are undefined because you can't divide by d. So no, Kramer's rule always works.
Yeah, great.
That's why we use it in mathematics and engineering.
Great. Thank you so much.
Thank you. Let's look at an event, an example where it's going to be inconsistent and independent. One minus 3y equals 1, -2x plus 6y. So first thing, let's create our matrices. The coefficients only. So it's 1, -1, and 1. -2, 6, and 5. Let's find our d. So 1 times 6 minus -2 times -3. 1 times 6 is 6. -2, -3 is 6. 6 over 6 minus 6 is 0. Let's look at dx. So we take the answers and put it in place of the x. 1, 5, -3, 6. One times 6 minus -3 times 5. 1 times 6 is 6. -3 times 5 is -15. That changes to a plus. 15 plus 6 is 21. Now dy. Remember, dy, I leave the x values alone and put the answer in the y column. So 1, -2, 1, 5. One times 5 minus -2 times 1. 5 minus -2, that becomes a plus. So dy is 7. So x is dx over d. 21 over 0. Undefined. You can't divide by 0. dy over d. 7 over 0. Also undefined. So what does this tell us? Since we have undefined solutions, that means there's no solution. If there's no solution, the only way that can be possible, both lines are parallel because they never meet. All right, so whenever your denominator, remember your d equals 0, your lines will be parallel. Let's see what it would look like if the lines were the same lines. Let's look at this example. So the coefficients, 1, -3, -2, 6, 2, -4. -1, 1, -3, -2, 6. 1 times 6 minus -2, -3. 6 minus 6 is 0. All right, let's test the dx dy. Dx. Take the answers, put it in place of the x column. 2, -4, -3, 6. 2 times 6 minus -3 times -4. 2 times 6 is 12. Negative is positive, of course, 12. The x is 0. And dy, take the answer, put it in the y column, leave the first one alone. 1, -2, 2, -4. One times -4 minus -2 times 2. -4 minus -4, it becomes a plus. -4 plus 4 is 0. Since all of the values equal 0, the dx, dy, we have an infinite number of solutions. They're the same lines. And that does it. That's the end of the course.
Well,
Finish
chapter
chapter 6.
6 is a breeze, really.
I know, that's what I said, is once we finish chapter 4, she gets a lot easier, because chapter 5 is just basic follow the rules. Chapter 6 is a breeze. And since I missed a week, a couple weeks ago, we won't have time to do 7 and 8, because this week is Thanksgiving. The week after that is review week, and then the final exams due the week after. And also, when I go home today, I have everything set up. I will send you all the videos and the notes that I've compiled so far. So in case you miss anything or you want to see something over, I have all the notes and videos ready to be sent out. I'll send it out this afternoon.
Great, thank you so